different ways to get there. I'm just going to go to the latest. So this is going to add the column back in the post table and then add the users table. And you can see that it went ahead and added the users table. So if I refresh this, we can now see that we have a users table, and hopefully all of the properties are there. You can see all of these have been set. Constraints, primary key is set, and everything else looks good. I guess one thing just to check is the created at. So if we check the constraints here, you can see that we're going to grab the current time. Perfect. All right, so after we had added the user functionality, the next thing we had to do was we had to implement the relationships between users and posts. So we had to set up that foreign key that linked the user table to the post table, or the post table to the user table. So once again, we're going to do an Alembic revision -m. And I'm just going to say add foreign key to post table. All right, we got our new revision. And what we're going to do is first of all, we have to add a column to our post table called owner ID. And that's going to be the one that has the foreign key constraint. So we have to do op.add column. And we have to specify the table we want to add the column to, which is going to be the post table. And this is going to be sa.column. We're going to call this owner_ID. And it's going to be a type of SA integer. And nullable is going to be set to false. All right, so we've created the column. Now we have to set the link between the two tables, which is going to be the foreign key constraint. And so to do that, this is a little bit confusing at first for me because the documentation is a little bit hard to read sometimes. So you do create foreign key. Then you have to give it, some arbitrary foreign key name. I'm going to call this posts_users_fk. So this is the foreign key between the posts and the users table. And then we have to specify what is the source table of the foreign key. So this is going to be the foreign key for the post table. So we're going to say source_table equals posts. Then we have to reference the remote table, which they call a referent_table. And so this is going to be the users table. And then we have to specify what is the local column that we're going to be using. So the column in the post table. And that's going to be owner_ID, which is the table, the column that we just created. And then finally, we have to specify the remote column in the users table. And this is going to be set, and we're also going to set the onDelete to be cascade. And yeah, by the way, the remote column is going to be the ID field of the user table. And we want to make sure we have the onDelete as well. And that pretty much, what happened there? It's a weird way to format things. All right, well, it wants to format it that way, so I'm just going to leave it like that. Let's set up the downgrade now, so we have to undo those changes. We'll do op.drop_constraint. And then we just mentioned the name of the constraint, which is post_users_fk. We have to specify the table that we're removing it from. So it's on the post table. So we do table name equals posts. And then we have to drop the column. So we do op.drop_column. And where does this column sit? It's in the post table. And it's called owner_ID. All right. And so if I do an Alembic current, we're on F52 and Alembic heads. Let's see what the latest one is. It should be 296, which is this one. So let's do an Alembic upgrade head. Go to the latest. And I have a typo, so this should be integer. All right, looks like it ran with no issues. Let's double check that the foreign key is there now. If we go to posts, properties, constraints, foreign key, you can see that we have our post user FK And we can see that it points from owner ID in the post table to ID in the users table. And if you want to, you can go under actions and see that cascade has been set to on delete. Now in our post table at the moment, we didn't implement all of the columns that we actually have in our application. So I figured, why not just go in and add it? Might as well. So I'm going to create a new revision. All right, and then we go to that revision. There's really only 2 more columns that we have to add. And this is, I'm once again going to just copy and paste from my notes just because I don't want to waste your guys' time too much. But you can see here, we're going to do an add column and we're going to add it from our, add it to our post table. And then here we're going to specify the parameters of the column. So this is going to be called publish. It's going to be of type Boolean, and nullable equals false. And that's not correct. It should actually be nullable equals true. Right? It should be, actually, no, it was false. And then server default is set to be true. So if we don't provide it, it's going to assume it's true. And then the next one is the column for created at. So once again, at the post table, we're going to create a column called created at. It's going to be of type timestamp, nullable false, and then the default means we're going to grab the current time. And to downgrade, we're going to delete those columns. All right, and let's do a Alembic upgrade. And we'll just go, instead of doing head, we can just do +1 just to show you guys how it's going to do the same thing in this case. And so it looks like it ran that. And if we go back to Postgres, refresh this, and then go to properties, we should see we've now got our published and our created at columns. All right, and once again, let's say that maybe we want to roll back, right? Maybe we want to roll back all the way to back when we just created the post table. We can once again do Alembic downgrade and just provide the revision number of the specific revision you want to go to. So we can go down to add user table. We can go down to create post table. We can go down to any section we want. And it's really up to you. And so let's say this time, let's just go all the way down to, let's go down to add user table. So whatever revision this is, we can do that. All right, and so it deleted a whole bunch of stuff. Looks like it deleted the last few columns that we just added, as well as the foreign key constraint. And so now, if we refresh these tables, you can see that posts, it doesn't have the extra columns we added, and the constraints, foreign key, no longer exist. But fortunately, we can upgrade to a newer version, to one of the more recent versions. So I can do Alembic upgrade +1. So if I do this, it's going to go up 1 newer revision. So right now we're at the add user table. And if you forget wherever you are, you could just do Alembic current. All right, so we're on 32F52. And so if I do an upgrade, right, we're going to go up to, I think it's this one. Because you can see that in this one, this revision is 296, but the previous revision is 252, which is the one we're currently on. So I can do Alembic upgrade +1. All right, and so now we've added the foreign key. If I do Alembic current, we can see that we're on 296. And then if I just do Alembic upgrade, well, Alembic heads, it's going to show us whichever one's the latest one, which is 5B7. So we could just go upgrade directly to that by doing head. The last thing that we have to do now is generate the votes table. But I'm not going to manually create it myself this time. Instead, I'm going to make use of the auto generate feature. So this is what I was talking about earlier, how we can use Alembic to be intelligent enough to figure out what exactly is missing from our Postgres database and figure out what needs to be created. And the way it actually does that is it takes a look at all of our models. So it's going to import all of our SQL Alchemy models, and based off of the columns that we have set here, it's going to figure out what our Postgres database is supposed to look like. And regardless of what our database is in its current state, we don't need to actually delete everything and build it from scratch. Instead, Alembic is going to be intelligent enough to figure out what columns are missing, what tables are missing, what extra columns do we currently have that we may need to remove, and it's going to figure out what's different between SQL Alchemy's models and our Postgres database, and it's going to make the necessary changes for us. And so the way to do that, and first of all, I guess just to kind of reiterate, the reason we can do that is because we imported the models and then we passed it into this target metadata. So let's run Alembic and we'll do revision. But if we do --help, you'll see that we're going to use one of the flags that we have never used before, which is the --auto generate. So we'll do --auto generate. And then we will send a message once again. We'll say add votes. How about auto vote? Maybe. Because it's auto-generated and I know it's going to add the votes table because that should be the only difference that we have. So we'll run that. And so if I go to auto vote, let's take a look at the changes it's going to make. And so you can see here the changes where it looks like it's going to create the votes table like I had predicted. It's creating the 2 columns, and then it's going to add the primary key constraint as well as the 2 foreign keys as well. And it's going to even add in all of the on-delete properties and things like that. All right, and so all we got to do now is do an Alembic upgrade head. And now if I refresh this and go to votes and properties, right, we should have the 2 columns, and then our constraints and foreign keys look pretty good. Everything looks set. And so that's how easy it was. So no matter what state your database is at any point in time, you can always do the auto generate functionality to get it back to a state that your code expects it to be. And the best part about this is moving forward, let's say I want to go back to my models and I want to change something. So I've got my user model. This time I'm going to add that phone number column. And this is going to be string. All right, so any changes we make, even on a table that already exists, what we can do now is I can do a revision auto generate. Here I can just call it add phone number. All right, and then if we go take a look at that, we can see that, hey, look, we added our phone number column. And so the only thing else we have to do is do an Alembic upgrade head, and it's going to push out those changes. So let's refresh this and let's just double check. We go to users now, properties, we can see phone number column is now set. And I think that's pretty much going to wrap up everything I wanted to cover from Alembic. So moving forward, now that we have Alembic, we no longer actually need this command in our main.py file. This is the command that told SQL Alchemy to run the create statement so that it generated all of the tables when it first started up. But since we have Alembic now, you no longer need this command. However, if you want to keep it in, it's not really going to break anything. It just depends on how you want things to work, because if it does create the tables for you, then your first Alembic migration isn't going to have to do anything because everything is already there. But I'm going to leave this commented out moving forward because I don't really need it. And it's really up to you guys for what you guys want to do. For the most part, throughout this course, we've been testing our API by sending a request from Postman. And Postman's a great tool, but there's one thing to note, and that is that when you send a request from Postman, you're actually sending a request from your own computer. And it's important to understand this because your API can get requests from different types of devices. You can get a request from a computer or a server, whether that's through Postman or even through curl. If you've ever used curl, it's essentially doing the same thing that Postman's doing. It just doesn't have a nice little GUI. You can also get requests from mobile devices, but more importantly, you can get requests from a web browser. So when a web browser sends a request, using JavaScript's fetch API, there's going to be a slightly different behavior that we have to account for which we can't take into consideration when sending requests with Postman because Postman isn't a web browser. So what I'm going to do is I'm going to show you exactly what happens when we send a request from a web browser instead of our own computer using Postman. So what I want you guys to do is open up your web browser and specifically go to google.com. It's important that you go to google.com, or technically this is going to work on any website, but I need you to actually go to a specific website like google.com. And then I want you to right click on the web browser and just hit inspect. So this is going to open up the Chrome Developer Tools. And if you aren't too familiar with it, don't worry. It's just it's a built-in tool that we have in Chrome or any web browser that allows you to makes it easier as a web developer to kind of troubleshoot things. But what we can do is if you go to console, we can actually send an API request to our API from google.com or from our web browser, which is on the google.com domain at the moment. And so I want you to just type this in. We're going to say fetch. So this is how you perform an API request from the web browser level. And we're going to send a request to our fast API. So that's going to be hosted on http://localhost:8000. And then just type in then. So don't worry too much about this, but it technically returns a promise. So we have to resolve the promise. We just say res.json. And then do another then and just say console.log. And I forgot one bracket right here. And so all this is doing is it's sending a request to the root URL of our API, and then it's going to print out the contents of whatever we get back from the server. So when I run this, I want you to notice something. We get an error. It says access to fetch localhost:8000 from origin, and then it has google.com here, has been blocked by CORS policy. So what is happening here? Why is it that I can't send a request from the web browser, but if I go to Postman and I just create a quick new request, and we can just go straight to URL, it resolves just fine. Well, it has to do with this CORS policy. So in this lesson, we're going to take a look at what exactly this CORS policy is and what we can do to ultimately resolve this issue. So what exactly is CORS? CORS is short for Cross-Origin Resource Sharing. And so CORS allows you to make requests from a web browser on one domain to a server on a different domain. And by default, when you configure an API, whether it's in Fast API or any other framework or language, you will only be allowed to send requests from a web browser running on the same exact domain as your server. And so what exactly do I mean by that? Well, if our API is hosted on google.com and our website is hosted on ebay.com, ebay.com by default cannot send a request to an API running on a different domain like google.com. It's going to get blocked by CORS. However, if our website was also running on google.com and our API was also running on google.com, then they'd be able to talk just fine by default. And just to prove that to you guys, if we go to our web browser and go to localhost:8000, which is the URL that our application is currently running on, you can see that I get a response back. So our web browser was able to make, and by the way, when I did this, right, it did the same thing as going into Chrome Developer Tools and actually sending a request. And just in case you don't believe me, I'm just going to actually just show you guys even on here. So if I paste it, you can see that it was able to resolve and we can see the hello world. So the reason why it works on this website is because this is the same exact URL or domain name that our API is running on, right? Our API is running on localhost:8000. So by default, they're able to talk to one another only when the web browser domain is on the same exact domain as the API's domain. So to fix this, if you did want to allow people from other domains to talk to your API, what you can do is take a look at the Fast API documentation and just search for CORS, Cross-Origin Resource Sharing. And you'll see that setting this up is really simple. So the first thing that we have to do is from Fast API, middleware CORS, we're going to import CORS middleware. All right, and then just copy this section right here. And I'll explain line by line exactly what each one's doing. And so under the app right here, we'll just paste this in. And it's going to throw a little error here, but we'll come back. You can actually delete that and change that to an array for now. But what we want to do is, first of all, we have to pass in the middleware. And middleware is a term that's used in most web frameworks because it's basically a function that runs before every request. So if someone sends a request to our app, and before it actually goes through all of these routers, it'll actually go through the middleware, and then our middleware can perform some sort of operation. But what we want to do is, first of all, we have to specify the origins that we want to allow. So what domains should be able to talk to our API? Because right now it's no domains. Only if it's running on the same exact domain are you able to talk to our API. So the way we can do it is we can put in, we'll create a list called our origins. And I'll say origins equals, and it's just going to be a list. And here we're going to provide a list of all of the domains that can talk to our API. And before we fill that in, I just want to quickly talk about the other three as well. So our CORS policy can be pretty granular. So not only can we allow specific domains, we can also allow only specific HTTP methods. So if we were building like a public API where people can just retrieve data, we may not want to allow them to send post requests and put requests and delete requests. So we could potentially just allow GET requests. And then we can even allow specific headers as well. But for now, we're just going to allow all headers and all methods. And we're going to just kind of drill down based off of what origins can talk to us. And so, if we want Google to be able to talk to us, I can just say https://www.google.com. And so now this CORS policy is set to allow people from google.com to talk to us. And so if I go back to google.com, I just hit the up arrow so I can run this command again. You'll see that I do successfully get a response back and there's no CORS error. However, if I go to a different website, so some website on a different domain like youtube.com, and then we go and then we send the same exact request from the console, right? We once again get the CORS error. And that's because in our list of origins, we're not providing www.youtube.com. So if you wanted to also allow youtube.com, then we'd have to do https://www.youtube.com. So now if I hit the up arrow, we can see that it properly resolves. So you just have to provide the list of URLs that can talk to your API. And if you want to set up a public API so that everyone can access it, then your origins would just be a wildcard. So this means every single domain or every single origin. But if your API is being configured for a specific web app, then you definitely want to make sure that you provide a strict list of origins. So just whatever domain your web app is running on, so that no one else can, accidentally reach our application for some reason or another. It's just security best practices to really narrow down the scope of the origins that can actually access your API. For now, I'm just going to leave this as set to everyone so that when we actually go to deploy this, it'll be a little bit easier from a testing purpose. But feel free to update this accordingly. In this lesson, we're going to focus on setting up Git for our project so that we can start tracking our changes, as well as set up a remote repository to store all of our code. This is going to make the whole deployment process a whole lot easier. But before we set up Git, there's a couple of things that we need to do. Because when you check your files into Git, by default, it's going to check in all of your files. And there's going to be some files that you don't want to be uploaded to a remote repository or even into your Git in general. And so we have to create a file called a gitignore file. And so if you go to the main root folder of your project, I want you to create a file called .gitignore. And it's important that you put the dot in front of it. So it's .gitignore. And so this file is going to tell Git what are all of the files and folders we don't want uploaded to Git. And so some of the common things that you would not want to be tracked within Git is going to be your .env file. So this is going to be all of your environment variables. Obviously, you don't want to check those in, or then if this is part of a public repository, then anyone can see those. But also on top of that, you'll see all of these random PyCache, these underscore PyCache folders. So go ahead and add that in there as well, because we don't actually need to check that into Git. And then finally, we have our folder which contains our virtual environment. We don't want to check that in as well, just because we have no idea if someone else who wants to clone our repository is going to be using a virtual environment And if they are, then they can create one on their own. There's no need for us to actually upload our virtual environment. It just wouldn't make sense. And on top of that, our virtual environment contains all of the third-party libraries that we've installed. So all of the different packages we installed through pip, including Fast API itself. So all of the code of Fast API is within that virtual environment folder. And so there's no need to actually upload all of that because that's a lot of files that actually take up a decent amount of space, and it just wouldn't be efficient to actually upload those to Git. However, this does create one bit of an issue because if we clone the repository at this point, right, we have no idea what packages we need to install because our virtual environment didn't get uploaded with it. So we need a way for other users, other people on our team to know what packages and dependencies we need our application so that our application actually works. And so the way that we actually do this is, well, first of all, before we even proceed, go ahead and copy this into your git ignore file and make sure you have this before you do anything else, because once certain files get checked in, it's very hard to get them removed. But after this, what we want to do is we want to create one more file and open up your terminal. And what we're going to do is type in pip freeze. So pip freeze is going to dump out all of the different packages and libraries that we have installed, as well as the specific versions. And so this is the information that we want to upload to Git so that if anyone else clones our repository, they'll know the exact versions of every package they need to install. So what we're going to do is we're just going to take this output and we're going to pipe it to a file. And the file name is going to be called requirements.txt. So this is standard convention with any Python application. You want to create a requirements.txt file that's going to contain the version of all of the different packages that you have installed. And so if we check this into Git now, then anyone else can just take a look at our requirements.txt file and then actually install dependencies based off of what's in this file. And so for anyone else that clones our repository, all they have to do, instead of going one by one and installing these, they can just type in pip install -r requirements.txt, and that's going to install everything that's in this file. So this does simplify the process, and it prevents us from having to upload all of those third-party packages into Git. But we've got everything set up at this point. We've got the git ignore file, and we've got the requirements.txt. So what we need to do now is actually set up and install Git on our local machine. If you don't already have Git installed, then in this lesson, we're going to focus on getting installed on your local machine. So just search for Git, and then you can either go to the main page or you can go straight to the downloads page. So I'm just going to select the downloads page. And then here you're going to see the different operating systems we can install Git on. And so just go ahead and select your respective operating system. I'm on a Windows machine, but regardless of your operating system, it's going to be a fairly similar procedure. So I'm going to select this. It's going to download that. All right. And then when the wizard opens, go ahead and select next. Next here. And you can leave everything default here as well. And here and here. Now, this is the one thing that we do have to change. So this is kind of a little bit of a nuisance at this point, but they used to call like the main branch the master branch, but I guess people are offended by that. So now the new term for the main branch is main. So go ahead and override the default branch and just change that to main. Because when you work on GitHub, they've already changed the default branch to be main. So we're going to want to do the same thing. So hit next. And then you can leave everything as default moving forward. There's a lot of windows to go through. And then it's going to proceed to install Git. All right, close that out. And then what you want to do is open up a new terminal. And just type in git -- version. And if it spits that out, that means you've got Git successfully installed. In this video, we're going to set up a remote repository so we can store all of our code on GitHub. And so if you don't already have an account on GitHub, go to the main GitHub page, just go to github.com and just click sign up and then follow those instructions. And then once that's done, just log in and you should see something similar to this, although you may not see an activity window if you just created a brand new account because you won't have any repositories. But just look for a new button to create a new repository. You can also go up here, I believe, and select new repository. So I'll select new. And then we have to give our repository name. You can give it any name you want. I'm just going to give it a dummy name. So this is going to be example Fast API, but name it after whatever your project is. Technically, I've already set up Git for my project just so I can track all the changes I've made throughout the course. But I want to make sure that I can walk you through this if you've never done it before. You can give it an optional description, and then you can choose whether or not